Security and Privacy, Internet of Things is the title of the keynote of Felix Bauer, CEO and founder of Aircloak. Felix, come on up. The stage is yours.
Hey, thanks for having me. OK, here we go. So I'm here to talk about security and privacy in the Internet of Things. Just to start off with this, and if it's the only thing you take with you today, it's really freaking hard. I mean, this is a huge topic. Actually, it's so huge that Cisco, for example, launched a contest last year that was just concentrated on how we can secure the Internet of Things. And incidentally, we won that. So this is my background on this. I'm trying to give you, a few hints in the right directions. But rest assured, I'll only scratch the surface. Please go and investigate further if you're interested. So we just heard we'll have millions. Sorry, yeah, perfect. We'll have millions of smart meters and billions of connected devices. We were asked about the number of data we'll have. This is actually what we're looking to have in 2020. 44 million gigabytes, so that's 44 zettabytes of data in 2020. And keep in mind that already today, we delete nearly all of the data that we get immediately, because we have no way of handling them. So this is what we assume we'll have in 2020. Now, what most people don't tell you is that actually 40% of this will be private or sensitive data. So sensitive is like private data, but even worse. OK, like medical, political affiliations, and stuff like that. So here's the problem. We're really damn bad at handling private data. We're really bad at keeping them private. Even if we try our best and we throw all kinds of things in the way in order to protect what is important to us. And we anonymize all we can. In the end, it always comes out. Now, I don't want to leave this with Simpsons and actually go to a real-world example here. This is quite recent. The taxi data in New York City. So New York City, they're proud of their taxis. They thought it's a great idea. We'll just release our taxi data, and then people can do all sort of cool analytics on it. And this was a good idea until it turned out that what they did, the anonymization that they did on this data, was really bad and not properly done. So this guy, Vijay, he wrote this cool article on taxis and rainbows. I can recommend that to everyone. It's quite concise and nicely written, and you can learn something about anonymization there. So what these guys did is, they released the taxi data. This is something I recorded on my computer. If you have faster internet, then it will even load properly for you. Day in the life, I can also recommend that. It's quite nice. So you see taxis driving through New York. They pick up customers. They drop them off. You see a little bit how much money they make. And of course, if you want to release this information, it needs to be anonymized, right? Completely clear, because I don't want to be able to go back and look at the driver and say, oh, wait a second, this driver, where's he living? I can see where he starts every morning. How much money does he make? All that is private information, none of my business. So these guys tried something, which they heard works, and it really doesn't. So please don't try it at home, but I'm going to tell you what they did. So every taxi has a driver, even if it's not Robert De Niro, but it has one, and that guy has a license number. And the taxi has a medallion number. Now, what they did is they hashed these numbers. What is a hash? For everyone who doesn't know that, I put in some. Where's my pointer? It's not here. OK. Anyway, I put in some number, and I always get a 32-digit key. In this case, in the MD5 hash case, and the point is that hash that I get in the end, that is unique. So the driver will always have the same sort of scrambled number, and the taxi will always have the same sort of scrambled number. The idea is, if I just have the number, if I just have that hash, I have no way of getting back to the original data. And that's true if I just have the number. Who of you hasn't seen the Imitation Game? Oh, very few. OK, very good. Very few spoilers. If you still want to see it, cover your ears. But you know how the war ended, so it's not that much of a spoiler. So these guys have been facing the exact same problem, right? There was an encrypted message. They get these encrypted messages from the Germans. They want to decrypt them. So finally, they get that computer to run. And they realize, hey, it's taking far too long. I have to plow through all these data. It's a lot of data. What do I do in order to make it more manageable? Now, they realize, wait a second. Every message in the morning, the first thing that they send is the weather report. And of course, they end the message with Heil Hitler. I'm not even sure if I'm allowed to say that here. So, and so they can prime the computer, and the computer calculates through these messages a lot quicker and gets to the answers a lot quicker. Now, this was 75 years ago. That's when we knew that, OK? And we're still making the same mistakes. Because even if you apply a hash to this number, we know something about these numbers. We know, for example, that driver license number is a 6-digit number, or it's 7-digit and starts with a 5, which is in the end the same, the same amount of possibilities, 3 million combinations. And that medallion number also has a very specific way of being built up, which gives us 19 million combinations for a grand total of 22 million. How long do you think it needs a modern computer to brute force through all these 22 million combinations? Guesses? A little bit under 2 minutes. That means we get from a completely anonymized database to a completely de-anonymized database in under 2 minutes. Fun fact, legally seen, data is anonymous if it takes you a disproportionate amount of effort to get back to personal data. If you need a lot of work, time, money, you need to punch all that stuff in there. And only if you really spend a lot of energy in this, then you might get back to some single individuals. Not in this case, 2 minutes. OK, to be fair, it takes 2 minutes and then an hour because you need to cross-reference them. But still, it's not a lot. Why did that happen? Because this database is actually not anonymized. OK? It's pseudonymized. This is a really important point I also want you all to understand. If I replace a unique ID with another unique ID, that is not anonymization. If I take away your name, because I say I don't want anyone to know it was you, but I give you another unique number, and I can tie these numbers together in the end, that's pseudonymization. Now, this is important, because I want to know, hey, that taxi driver that was here on day 1 and that was there on day 2, it's the same guy, right? Even if I don't know the name. So I need to do something like this, but it is not anonymization. So what, you could say, right? We know a little bit about the taxi drivers. We know a little bit about the taxis. It's not so bad. Turns out, you can always play this game further. So in New York City, there's this guy, Bradley Cooper. Some of you might have heard of him. He gets into a taxi. Of course, there's a photographer around, films him. And immediately, you can read off the license number of the taxi, and you know where the guy was going. And because we're gender neutral here, Jessica Biel for the guys. OK, we also know where she was going. Interestingly, this sparked a discussion about how much celebrities tip in taxi rides. Also quite funny to read. All right. So this is a typical problem, because of course it's also very powerful. I have some data that might be, more or less harmless, but I add some external knowledge to this. In this case, I know how the New York City taxi plates are organized. So all of a sudden, that data gets a lot more valuable. And then I add another external piece of knowledge, which taxi Jessica Biel was taking, and suddenly, boom, this just explodes. I have a huge database of personal data for anyone who took a taxi in this long amount of time. It's 173 million taxi rides in that database, and it's out in the public. OK, so now is the crux. Internet of Things, it consists of a lot of additional information. That's the whole point. We want to tie them together. This is exactly where the power is coming from. We know what you've been shopping. We know your gas and your water consumption. And we know your favorite websites and who you're stalking on Facebook. Now, this stuff, combining that, of course, is extremely powerful. And it can lead to a bright future, but it also can lead to a lot of problems. So currently, what are we doing? We're creating every data scientist's worst nightmare, data silos. OK? We try to keep these data separate. All these companies get these data from all these thousands and millions of sensors, put them in their little silos and say, hey, OK, we need to keep them private. We only give a few people access to this. We only release very, very select information. And of course, they have to, because there's a lot of fear and a lot of danger connected with this. And this is where the Internet of Things will fall short. I'm sure of it. So how do we solve this? Now, little bit of self-promotion, and I'm not saying I'm offering you the only solution, but it might be a solution. I'm currently working on Aircloak with my team. We're a spin-off from the Max Planck Institute for Software Systems. There's many years of research going into this, and we hope that we have a solution to that problem. So imagine you have, actually here's my T-shirt. Just I'm going to take that off. OK, so here you have all the different data sources. Now, instead of taking a data set like the taxi data and anonymizing it and then doing the analytics on it, which we know will be dangerous, especially if we want to combine it with other data, we take all these data, we encrypt them, and send them to a central system. This is a nicely scaling cluster system. Now, no one has access to the data ever, ever, ever again, as soon as they're encrypted on the end-user device or in the original database or whatever it is. And by no one, I mean really no one. Also not us. Also not the administrator of the system. Also not the technician of the database. Also not the police. No one. But you can ask that cloak, this black box, you can ask questions. And it will answer you. And these answers is then what is filtered in the end. OK? Now, I told you, yeah, there's a lot of research, and we have a number of patents on this. But still, why would you trust us that we're doing this? You shouldn't, actually. I would be happy if you don't. I would be happy if you check yourself. We release that code, and any auditor can check that code. And we give you cryptographical proof on hand that the code that is running on our system is 100% the same code that you see online. And we cannot cheat. We cannot build in a backdoor. And if we do, then you will see it. So this enables us quite a lot of things, because it gives us a very nice legal status. You can work with richer data sets. It's a turnkey anonymization that works with any kind of data, and it works in real time from any number of sources. And there's a huge amount of transparency that goes into this, because we really don't want to be a party that you have to trust. We want you to be able to oversee it yourself. OK, enough of us. The main points of my talk right now. Pseudonymizing is not the same as anonymizing. Don't make that mistake. Real anonymization is freaking hard. The guy who did this taxi data stuff, who found out that there's a lot of personal information in there, he suggested some better measures himself. And then they figured out, wait, even this doesn't work. It is really a really tough problem to crack. This leads to data silos, and it leads to distrust, especially here in Germany, especially in Europe. And I'm sure that the Internet of Things is in danger because of this. We need to find better solutions, and these solutions have to be technological, and they have to be clever, and they have to go beyond what we do so far. Aircloak might be one, but if you have another one, please come to me and talk to me, because I want to solve that problem. Oh, I have to stand over here. That's me, Felix. This is the startup, Aircloak. Check us out online, follow us on Twitter, all that stuff. If you have questions, go to me. Thanks a lot.
So did you have any speaker coaching in the US? Great talk. Great way how you present your cause, because it sounds like a cause.
Yeah, no. The US, of course, they're a big, big idol, but yeah. OK.
Well, there's a lot of talk that Germans can't sell. Here we got the exception to the rule accent. Tell us a bit about the stage of the company is in right now.
Yep.
Are you looking for more money, I assume?
Yes, eventually. Currently, we're running a number of pilot projects with quite big corporations. So obviously, this is a problem that especially big companies or organizations, cities, and so on have. We're looking at scenarios where there's a lot of people involved. Trust is a major issue. And many of these people who are involved don't even know that their data are being touched. So you want to keep it really, really secure. This is done by major organizations. So currently, we're running pilot projects. And eventually, around summer, we'll look for a little bit more funding. Yep.
Excellent.
So I'm also happy if you contact me.
Did you have any good leads yesterday? Did you have good talks?
Yeah, actually, I arrived a little bit later yesterday. But Cebit is always great. and I've already made a couple of good contacts. So,
Oh.
yeah.
Well, this was a very inspiring, high-level talk. And although you were selling well, you put a lot of content in it, and we're grateful for that.
Yeah,
Thank
I
you,
hope
Felix.
it wasn't too much, and thanks a lot for giving me the chance to be here.
Excellent, really excellent talk. And where's your booth? Where can they find you?
Actually, we're in Scale 11 today from the other hall, Scale 11. It's not as cool as this one. I'm going to say that out loud right here. Yeah, we're going to be there at the European Young Innovators Forum.
Excellent. Thank you, Felix.
Thanks a lot.
All right.